Hello everyone, welcome back to the channel. In today's video, we are going to learn about AI fundamentals. Let me start with a very simple question. When you type anything in any AI model like ChatGPT, Claude, or Gemini, so any AI model, you will get response immediately. Have you ever thought what is exactly happening behind the scenes? It feels like there is a human kind of brain on the other side of the system, and they are reading my words, they are understanding my emotions, and giving reply accordingly. So it is all looks like a magic. Today, we will try to break down what is exactly happening inside any AI model. In that, let me start with first step, that is called tokenization. So any AI model, the first step is tokenization before giving response to us. So what is tokenization? Tokenization is the process of converting text into smaller pieces. We'll see here in this diagram. So I have the human understandable text, that is the cat sat. So this cat sat converted into or split into three different words. So three different words are, in this terminology, we call these as tokens. And then these tokens assigned with some numbers. The 45, cat 876 are set to 21. So that process is called, those are token IDs. So the complete process is called tokenization. So as we converted this we split it human readable text into separate tokens, and then we are assigning token IDs. If you ask me, why do we need this tokenization? So the reason is very simple. Any AI models are computers. They built on microchips. So these microchips can only understand numbers, zeros or ones. So zeros or ones. They cannot directly understand our human language. So that is the problem with our AI models or microchips. So we have to make our AI models understand that our human, what we are talking or what we are saying. So to understand, we are assigning some IDs. So these IDs are in the format of numbers. Then we process these numbers to our AI models so that they can understand or they can process these token IDs and do some analysis and give the reply to our prompts accordingly. So this complete process is called tokenization. The need is because of computers or AI models cannot understand our human text. So we need to split. So we need to convert our text into numbers. So in this process, first we are splitting our sentences into different tokens. Then we assign the numbers to that or token IDs to that. So this complete process is called tokenization, and use of that also. Now you understand why we are converting. So tokenization, in simple, tokenization acts as bridge between human language and AI format, so that AI models can process that. So this tokenization can be done in different ways. One is character tokenization, another one is word tokenization, and next one is subword tokenization. Then let me start with the first one, that is character tokenization. In the character tokenization, we are splitting our sentence or our words into different tokens based on the character. If you see here, C is one character, A is another character, and T is another character. Now we have split our word or our sentence into three different tokens based on the character. So this is called character tokenization. In this, we are directly providing token IDs to each character again. Let's say C 786 or any number that is from their A vocabulary. So when they train their models, they do this vocabulary thing so that they can assign exact token IDs based on that token. So that is the first method, character tokenization. The second one is word tokenization. In the word tokenization, the sentence divided based on the or split based on the words. So if you see here, I love cat. So we have divided into three different tokens. Three different tokens based on separate word. So this is called word tokenization. Again, the process is same. We assign some separate and some token ID to each token. So this in this terminology we call this as a token. So we call this, after separating, we call this as a token. Then we assign token IDs to each token. So here the token split it based on the words. So that's why it is called word tokenization. And the next one is subword tokenization. So in the subword tokenization, if you have the sentence like this, cat is unhappiness, then so the first word is cat. So we kept as it is, and is also same. And then we have the one big word that is unhappiness. In this, we are splitting this unhappiness into three different tokens. One is un, second one is happy, and the next one is ness. So one word divided into three tokens. So that's why it is called subword tokenization. The reason here is, let's say in character tokenization, let's say in character tokenization, if you see in character tokenization, if you see each character divided into one token, then if you have some big sentences, then it will become too many characters. Too many characters means too much of process required. So in this case also, it definitely works, like we can get the response and all the things. The problem here is each word or each sentence, if you take the big sentences, you are converting into so many different tokens. The reason each character is a token, then the process is more on the AI model side. They give the response that more process and there are more delays. So that is not the efficient approach. So then they have this word tokenization. They thought like word tokenization can solve that problem. So they have started using word tokenization and they split it based on the word. But the problem here is, this also works definitely, but the problem here is we have to train all the words. That means let's say cat, let's say like we have to consider a word unhappy, happy, happiest, happily, happiest, happily, happiness, unhappy, unhappiness. So that we have to train all the words. So this is also again difficult. So for one word, we have so many variations. If you consider whole text in the world, whole dictionary, it is too difficult. So the number of words becomes too much for the training purpose. That's where they thought like subword tokenization is useful. That means here unhappiness. So happy, and when we got unhappy as input, then it understand already happy means, like we already define what is the meaning of happy. So it can understand once, and then here also it can use, and then we do what is un, and then we do the relationship between unhappy. So that we no need to train. Like the training is little like the train. Once we train those models, it is easy to get that already defined meaning. And also if some unknown word came, let's say I have typed something else, then if we didn't train that particular word in the model training, while doing model training, then it will not understand what is that meaning of full word. So in this case, in the subword, we divide, and we will check, is there any relation that is with current words. So even though if we make some spelling mistakes, then also it can, once it is split, then it can understand, is there any subwords are already are in our AI models, and they can assign that token IDs, and they can get the context accordingly. So that is the extra benefit that we are getting in this subword tokenization. So all three methods works, but this subword tokenization is giving extra benefit that even if unknown words entered, we are able to split and we are able to refer the context. So that is the advantages in this subword tokenization. So that's why almost all the latest AI models like ChatGPT, Claude, or Gemini, they use this subword tokenization method. So in all models, once the text is split, they assign a token IDs. So they assign token IDs for each split, as we discussed earlier. So let's say here, what is a cat? After splitting in the AI model format, we are assigning tokens based on the tokenization method that was trained during AI models. That means here, for example, what is a cat? So what is cat? So we have splitted, and then let's say the cat got the token ID of 932 from their vocabulary. So it will get from the vocabulary of that AI model. So different AI models like ChatGPT, Claude, or others may have different token ID system. For example, the cat got 932 token ID in ChatGPT, in specific ChatGPT model. Claude may assign some different token ID based on their training vocabulary. So ChatGPT may get some different token ID for that same cat one. So it's based on their models during training. But within the one model, let's say like in the specific ChatGPT model, if the cat got 932 as the token ID, even if you type similar things like where a sentence contains cat, then again the same token ID assigned to that particular same word or same character. It's based on their tokenization method, but the value will be same. For today, if cat ID is 932, tomorrow also it will be the same in that particular A model. So once a token ID is assigned, so now token IDs are assigned to the tokens. So AI model process them using neural networks and predict the answer by calculating what is the mostly like next token or next word. So the first step, as I mentioned, the tokenization. So now we split our text into tokens, and also we assigned token IDs. So the next it will ask for like the neural network. In the neural network, we process these tokens. So once the token ID is assigned, everything is okay. But still, AI cannot do anything with that simple numbers, right? AI just has the numbers. It cannot directly predict all the answers. So there should be some relationships. So with these numbers, we feel like there should be some relationships. Then only AI can answer. AI can process those numbers and gives some meaning. With simply numbers, there is no meaning. So that challenge, that next challenge is teaching a relationship between these words and concepts. So that is where embeddings comes in. So embeddings place words and ideas into mathematical space where similar words close to each other. So these all comes like before neural network. So the internal part. So after tokenization, we assigned numbers means like token IDs. Still AI cannot directly guess all the things, right? So internally we have to map some relationships. So that relationships. So that is where this embedding space comes in. So this embedding place where words and ideas are closer to each other in our mathematical space. In the next video, we will explore these embeddings and see how AI learns meaning from these numbers. So thank you so much for watching. If you found this helpful, don't forget to like, subscribe, and share the video. Thank you.